Hello, today we're going to be solving linked list one, not linked list, Leet Code 141 linked list cycle. Given a head of a linked list, determine if it has a cycle in it. All right, so first, what is a cycle? A cycle is where you can get to a previous node by following each node's next pointer. So let's look at our example of a cycle. We point one points to two, points to three, and two is a previous node, but you can get there just by following three's next pointer. So that brings us back to two, and that would just happen indefinitely. So this would be a cycle. An example of a linked list with no cycle would be the top one: one, two, three, and then null. We don't visit. You can't get to any previous node by following the next node's pointer. It's impossible to get to one by just going through here, and that goes for any other node. You would just reach each node one time and reach null. So since we know that a linked list always visits a node more than once, we could use that to our advantage. And let's use a set. So we're gonna have a set called scene, and we're gonna check if the node we're currently at is in that set. Then we want to return true because that means we've already seen it. And if not, let's add it to the set and keep going. So let me explain how that works. Let's say first we go to one and add that to our set. We'll see two. We say two is not in our set, so we'd add it. So we visited two nodes. Next, we'd go to three. Now we visited three nodes, but three's next pointer points to two. So now we're looking at two and we're saying, is two on our set? It is. That means we've already been here. So this is indeed a cycle. So true. Let me rewrite that. True. All right, perfect. Let's use our same example with a non-cyclical linked list. So first we'd visit one, we'd visit two, we'd visit three. And since 3 points to null, we're done with our linked list traversal, and we have not seen any linked list, any node in our linked list more than once. Therefore, we return false. So let's actually code that up. First, I believe it's best. Let's start with creating our scene set. So let's scene equal new set. Let cur equal the head because we're going to traverse using the head pointer, but we don't want to manipulate or modify the actual head of the linked list. It's always good practice not to do that. Next, we're going to say while cur. So while cur is not null, so we want to make sure to traverse the whole linked list. We're going to say if scene has cur, which is the current node we're on, we're going to return true because that is a linked list. If it's not in there, we want to add it. So we're going to say scene dot add cur. And after that, we want to go to the next node. So let's say we're going to one, we've added one to our set, and now we want to go to the two. So to do that, we'd say cur equals cur dot next, because the next pointer of one would be two. So that's the next node that we want to check if we've been there before. And if you traverse the whole linked list and you have not met this condition, you want to return false. And let's see if this actually works. And there you go. We have solved linked list, well, not linked list, Leet Code 141 linked list cycle. Now, there's actually a more efficient algorithm to solve this, and I'll go over that next. But this is just the beginning one. It's the most simple and straightforward, so I want to show you that first. So the time complexity on this would be O of n, and the space would be O of n because we're adding everything to a set. There's actually a solution you can solve this in O of 1 space, and I'm going to show you this here. So we're going to come back to this, but let me show you what we're going to be doing. We're going to utilize two things, a two-pointer solution, a fast and a slow pointer. So fast is going to move two spaces, and slow is going to move one space. So let's say we have a cycle. So like one, let's let me grab this. So we're going to utilize our fast and our slow pointers. So they're both going to start at the head. So fast is going to start here. So fast is going to move up two spaces. So fast is here. and slow would move up one, right? Fast is going to move two spaces. So the next iteration, let's change this to another color. Slow will be here, and fast will come around and go one, one, two. So fast will actually be here as well. And if these two pointers meet each other, that means we have a cycle. Because, and I'm gonna explain to you why this works. So let's say, imagine you were on a track, right? And you're running at a constant rate of one. I don't know, 1 mile an hour or something. And you're the slow pointer. And you have a friend that's gonna race with you. And he's gonna be racing twice as fast as you. So he's gonna move at a constant rate of two. Eventually, while you're moving along, he is going to make up double the distance you are. Because while you move to one, he's at two. While you're at two, he's at four. Eventually, he's going to go around and he's going to lap you and come back to where you are. So if the fast pointer laps you, that means you're in a cycle. Hopefully that makes sense. And I'm going to explain why that works. So let me explain it with the math. So let's say we have let's say the length of this is like four. So like one, two, three, four, and our fast and slow pointers both point at the beginning node. Well, actually, that would be here. Slow and fast. Now, fast is going to move one step. So fast is slow is here, and then fast moves up two steps. So one, two. Let's look. How many spaces does it take for fast to catch up to slow? So in this current position, let's see. It would take one, two, three spaces to catch up to slow. So let's write that down. So it's three spaces. But slow is going to move up. So it's going to move up one and make the amount of space that it takes to catch it four. So let's say slow moved up to here. It would take one, two, three, four to get back here. So three plus one. But fast is also moving as well. So fast would move up two spaces. So that would close the gap by two spaces. So it'd be three plus one minus two. And what does that equal? This would be a negative one here. So it'll be three minus one. And that would give us two. So as you can see, the original gap was three, and now it's two. And if we were to do that again, let's say we had the two here, and slow moves up one space, so it adds to the gap by one. But fast is catching, so it's going to say move up. It's going to close the gap by two. Two minus one, this would be negative one. So negative one plus two would be one. So as you can see, the gap went from three, two to one. And when it eventually hits zero, that means they've met each other and it is a cycle. And just to explain a little bit further, if it's not a cycle, fast would just reach null. So let's say fast was here, it would go to here, and eventually it would go either out of bounds or null. And that's how you know it's not a cycle, because there is a null or out of bounds. And let's see how to code that up. So first we want to initialize fast. I'm just going to call it f for fast. So let f equal head, let slow, let s equal the head. And we're going to say while fast and fast.next. Because we want to make sure that there's always a next pointer to point to. Like, for example, if fast was here, we can't have it do another iteration because we're going to have it move up two spaces. So fast.next.next. The fast.next is null. Fast.next.next doesn't exist. Null does not have a next property. Therefore, it would throw an error. So you want to make sure to stop before we go out of bounds. So we're going to say, we want to say slow equals slow.next. So it moves up one. Fast equals fast dot next to show we're moving two spaces. And if slow equals fast, we want to return true because that is a cycle. And if it doesn't, we want to return false. And let's run that and see. Did we mess this up? Oh, I said while fast. It's while F. F stands for fast. All right, let's try that one more time. And we've solved the problem in all of one space. So now you know how to solve Leet Code 141 using a set and a fast and slow pointer. If you like the video, drop a like. And if you have any questions, just comment down below and I'll try my best to help you out.